Yo, what's up everyone? Patrick here, and in this next question, we got to simplify both of these compound fractions over here. So starting with number one, we got negative 4x over 5y to the 3 all over 3 over negative xy. So I'm actually going to take this first. I'm going to rewrite it as this divided by this. Right, this and this are the same, and I just feel like this is nicer to work with. Now, before we get into it, let's get the restrictions. So notice that y can't be 0, right, because it would make both denominators 0. And then x can't be 0, because it would make this denominator 0. And then when you're dividing by a rational expression here, you also want to get the restrictions from this numerator, the expression that you're dividing by, not this numerator, but this one, because if this is 0, then this whole thing is 0, and you can't divide by 0. But you could take 0 divided by a number, which would be like here. If x was 0, 0 divided by a number, that's just 0. But you can't take a number and divide it by 0. So you can also get restrictions from the numerator of the expression that you're dividing by, but in this case there's just a 3 there the whole time, so there's no restriction to get from there, right? 3 can never be 0. So those are the only two restrictions in this case. Then from here, what we can do is just simplify it. So dividing by a fraction means we would multiply by the reciprocal of that fraction. So notice there's like a negative 1 in front. Negative 4 times negative 1 is 4. X times x is x squared, then we have the y, over 3 times 5 is 15, then we have y to the 3, like that. Now 4 over 15, that doesn't simplify, that fraction doesn't simplify. Notice x squared, there's no other x to simplify with, so that stays, but now we got 1y at the top, 3 y's at the bottom, which would simplify to 2 y's at the bottom, right? Or 1 minus 3 is negative 2, y to the negative 2 is 1 over y squared. And then another way this could be shown is 4 over 15. That probably won't be shown like that, because there's two expressions in the denominator. It'll probably be just shown like this over here. A lot of times they take out the fraction if there's only expressions left in the numerator. So if this was like x squared, y squared maybe, then they may show it like this. But most likely the answer is going to be in that format. So this is the final answer, and then those are the restrictions right there. Now number 2 is going to be more tricky. There's going to be more algebra here. Notice that we have an expression here divided by another expression. So what I'm going to do is I'm actually going to take these two fractions, combine them into one, take these two fractions, combine them into one fraction, and then we could divide both fractions like we did over here. Because here we had two single fractions in the numerator and denominator, so we can go over here right away. But here, let's first convert this a little bit. So you can get the restrictions from here, actually, but what I would do is I would first combine these. Obviously, you could tell x is not going to be 0, y can't be 0, here and here. But the reason why you want to combine them is sometimes you can get another restriction from the numerator of this that you're dividing, but you can't see it necessarily here at this time. But a lot of times when you combine them into a single fraction, you'll be able to see it. So let me show you what I mean. If we have 4 over x plus 3 over y, what would be the common denominator between these? xy, right? So we multiply this x by y, so the top by y, multiply this by x, the top by x. So you'd have 4y plus 3x in the numerator. I'm actually going to, I'll put it in terms of alphabetical order, so 3x plus 4y. You don't necessarily have to, but I'm going to. So this and that bracket are the exact same thing. So we'd have 3x plus 4y over xy. So I'm going to continue this over here. So I took this bracket, converted it to this one, divided by, now what I'm going to do, same thing. So I'm going to take the 1 over x squared plus 1 over y squared and make it into one fraction. Now, common denominator between these, x squared, y squared. So we'd multiply this by y squared, top by y squared, multiply this by x squared, multiply the top by x squared. So then we'd have y squared plus x squared. Again, I'm going to put it in alphabetical order like that. So this and this are the exact same thing. So we'd end up with x squared plus y squared over x squared, y squared. So notice now we have single fractions like we wanted to, like I mentioned before. And then I'm going to take this and then further convert it to this fraction divided by this fraction. And I actually want to spend some time here talking about these restrictions. So again, as we mentioned, it's obvious x and y can't be 0 because it would make both denominators 0. It only has to actually make one of them 0, but in this case it's making both of them 0. So x can't be 0, y can't be 0. Those are the restrictions. Now, as I mentioned here, I'm going to mention it here, when you're dividing by a rational expression, you can also get the restrictions from the numerator of the one you're dividing by. But in this case, x squared plus y squared, that can never equal 0 unless both of them are going to be 0. Because notice if both of them aren't 0, then notice it's always going to be a positive number here and here, because even if it's negative, you're going to square the positive number. So another way you could show this is if you had like x squared plus y squared cannot equal 0, which means x squared cannot equal negative y squared. This can only happen when x is 0 and y is 0, because notice if we try to isolate for the x, we square root here, but then we can't square root this negative 1. So that's why we can't get a relationship between x and y. Okay, so this is only going to be 0 when x and y are 0. It can never be 0 otherwise, because then you'd have a positive number plus a positive number, which can't be 0. Now, this could have been trickier if this was, for example, let's say over here we had x squared minus y squared. Then, let's say this was in the numerator here, then this changes the game because we can get restrictions from here. This is a difference of squares. X minus y, x plus y. And then notice that x minus y can't be 0, so x can not equal y, and then x plus y can't be 0, so x cannot equal negative y. So we would add those two restrictions to these two if this was a minus instead. But because it was a plus, you can't get any other restrictions but these. But if it was a minus, just wanted to mention that you can get further restrictions, because then notice if x is y, if this was a minus, then you'd have x squared minus x squared, which would be 0, which would make this whole thing 0. You can't divide by 0. All right, so that's why I said to wait, put these as one fraction, and then get the restrictions, because sometimes you can get it from this numerator. In this case, we can't, but sometimes you can. All right, so anyway, just thought I'd mention that. And then what? From here, we just simplify. So 3x plus 4y over xy multiplied by the reciprocal of this, x squared y squared over x squared plus y squared. One of these x's, one of these x's. Actually, before we do that, let's combine these first. So I'm going to multiply this full out, and then I'll simplify it, just so we're not crossing out too much here. So we'll have x squared y squared times this expression. So this would end up being x squared y squared times 3x plus 4y all over this times this. So we'd have xy times x squared plus y squared. And then we could simplify from here. 2x's at the top, 1x at the bottom would leave us with 1x at the top. 2y's at the bottom, 1y at the bottom would leave us with 1y at the top. And then these, they don't cancel out. And we're just left with that x squared plus y squared in the denominator. So this is the final simplified format. Another format you may see this in, you may see this taken and distributed in the brackets. So we'd have 3x squared y plus 4xy squared. If this is a multiple choice question, maybe they'll give it in that format. This and that are the exact same thing. So just be on the lookout too. So you may get this, and then you may think that you didn't get the right answer because you don't see this on a multiple choice, but if you distribute, you do end up getting that. And yeah, that's pretty much all I wanted to mention. So those two formats, that's what this compound fraction simplifies to. Those are the restrictions.